Everyone, so today's guest is Britt Witham. So Britt is another Australian, and so Britt's originally from Melbourne, which is where my grandparents actually live. She's got a bachelor's in international studies from University of Saskatchewan, and then a master's in European and Russian affairs from Toronto. More recently, she started her own business, and what that business does is it's an online global event monitoring tool, and so she's actually out there in the field actually using data science in industry, which is, I'm just so grateful that she agreed to give us some of her time. Thanks very much, Britt. The reason we know Britt is because of Annie Collins. So Annie, did you want to say anything further in terms of introduction?
Yeah, sure. So I actually met Britt about 6 months ago. We were both sort of consulting on this data portal project, and I was tackling some of more of like the data analysis side and some of the data viz, and then Britt was brought on as more of the development, more web development side of things. However, with those types of projects, I ended up working a bit more on the coding side and development and developing some of those skills, and Britt was very, very instrumental in holding my hand throughout that entire process and guiding me through the world of Plotly. If anyone is familiar with that, sort of got thrown into the deep end with that. And Britt was very, very patient and very, very helpful in helping me navigate that world, in addition to all the data science and data analysis stuff that was going on with that project. And so I ended up leaving that at the end of last year, and we sort of kept in touch since then. And I thought in hearing about her work outside of that project that we were working on, that it was super, super fascinating, and selfishly really wanted to hear more about it in sort of this format. So I figured it would be fun to share that all with everyone that comes to the data workshop, and I'm very excited to hear what she has to say today. So without further ado, I will hand it over to Britt.
Excellent. Thank you guys so much for such great intros. I'm just going to go ahead and share my screen. Give me a thumbs up if it's all looking okay. Perfect. Okay, so let's jump right into it. So you'll see I titled my presentation today, Data Science in the Wild. And the reason for that is because once I took stock of all the things I've been able to do in my quite short career so far in data science, I realized that things are kind of wild. We're at a point where we're applying data science to problems as fast as we can innovate it. And I think that makes it a really exciting time to be involved in this discipline. So my goal is to illustrate the ways in which data science can be used as kind of like a superpower to solve problems in the real world. So I hope you'll allow me a bit of a gratuitous intro and a couple of case studies so I can tell the story of how I got so hooked on data science, how we use it at Geopolitica, and then also what's next from here. Because rather than formal studies, most of what I know about data science has come from my hands-on practical experience, just like working things out along the way. And I'll also say I don't consider myself a specialist either. I wouldn't say I'm 100% a data scientist or a data engineer or any one role. Rather, I'm more of a generalist who is really intent on researching and implementing solutions to niche problems encountered in various industries. So, oh, and last thing I'll say is that if you could save your questions for the end, that would be brilliant. So let's jump right in. So as was mentioned, I'm originally from Australia. I moved to Canada in 2008. That's why it's a bit of a hybrid accent, and eventually settled here in Montreal. But I took a bit of an unconventional path to where I am today. So, as you mentioned, I did a Bachelor of Arts and a Master of Arts along the way. I did my master's at the U of T in European and Russian Affairs over at the Center for European, Russian and Eurasian Studies on Devonshire Place. And from there, I jumped right into private industry. I worked in business intelligence and video games before starting Geopolitica. And along the way, like I said, the data science side of things was very self-taught. It was mostly on the job. There were a couple of boot camps along the way, but it was really a matter of figuring it out along the way and applying things as I learned them. And of course, that's thanks to the accessibility of resources and learning in this space, which is just phenomenal. And I think I'm probably preaching to the choir, but it's very much worth taking advantage of. So today, I wear a few hats. What we'll focus on today is my work with Geopolitica, where I'm a founder of what is, of course, a startup. So being a solo founder means I do all the business side and I lead the programming side. So I've been prototyping our new product with the help of a small team, and I'm excited to show you some more about that. And then I also work as a data engineer at an organization called Giving Tuesday. Giving Tuesday is the idea of donating money after Black Friday and Cyber Monday. So I work on their data team to build pipelines to handle tracking all those transactions. And then I'm also the technical lead at Solve, which is another startup which sells online subscriptions for Sudoku puzzles, where I was brought in to digitize and automate much of their offerings. So you can kind of see that if it involves data science or programming in an unusual place, I'm all for it. So that's my kind of intro. So going into a little more in depth, so I wanted to talk about how I use data science during my very academically inclined master's degree. So I did my MA between 2016 and 2018, which was just a super weird time to do a master's in politics because we'd just seen Brexit happen earlier that year, and then the Trump election happened in my first semester. So it was really this point where like nothing was making sense. What we were reading in the textbooks didn't really seem to line up with real life. And it was against that backdrop that I studied illiberal democracy. So that's kind of the idea of democracies that don't really follow the rules. It's often used for countries like Hungary, sometimes Turkey. And I was curious as to whether the US and the UK were starting to go in a similar direction. But the problem was there was this prevailing belief that only weak democracies could kind of act on illiberal values like sort of like exclusion, intolerance, or outright xenophobia. So for example, we were starting to see successful referendums that opposed like all forms of immigration and so on. But the data that was informing that notion really wasn't great. Most of the time it was kind of based on a spattering of surveys. Some of the time the results weren't statistically significant, and I found that kind of upsetting. So I went to look for new data. And I was on a research trip to London in 2017, doing some interviews, gathering context, trying to figure out what happened with Brexit, when I met a professor at the London School of Economics. Maybe some of you are familiar with him. His name's Kenneth Benoit. And he, yeah, looks like that, yes. So he's known for his work in developing packages in R to help with social science research. And so that chance meeting was actually what sparked my curiosity for programming. And I went on to incorporate those techniques in my research. So in this particular case, I leveraged textual analysis to show that illiberal sentiments can be the same in both strong and weak democracies. So the idea being it doesn't really matter how strong your democracy is, you might still see unusual results, which was a lot more controversial at the time. In the last couple of years, maybe things have changed around a little bit, but it was really cool to use data science to kind of cast a new light on this problem. And ultimately, kind of contribute to the debate of what, being a democracy really means. So it was very cool to learn a new technique to unearth new data and make that contribution. So switching gears a little bit, so this one's way more practical. This is when I was working at the business intelligence startup, which also leveraged AI. This was right after my master's degree. And this company's algorithm predicted the likelihood of company growth, as in physical expansion to new locations. So our clients were really interested in meeting these fast-growing companies at trade shows, which if anyone's been on the trade show circuit, you might know that they tend to happen all around at the same time in either autumn or spring. So in this case, like I said, I wasn't working on the algorithm, but I was actually on the data team responsible for uploading all this trade show information. But the problem was it was pretty analog in nature. We're looking at a lot of Excel spreadsheets, a lot of web pages, and there wasn't really enough time or people to process the information for the platform in time for trade show season, because the lists of exhibitors at these trade shows usually come out like 2 to 4 weeks before the show. So you can imagine it was a bit of a crunch. So in this case, the solution was our team made automatic web scrapers and data pipelines that automated all the manual work of getting those details and processing the data to upload to our platform. And once that was all set up, work that used to take me a whole day to do by hand could be done in an hour. So that was an 8-fold efficiency increase. And the take home from this was that because we were able to get the information on the platform faster than any of our competition, we were starting to get ahead of the game just on this feature alone. So that was really kind of a triumph for data science and also the data engineering that's kind of inherent in that whole process. And then so shortly after that, I went to work with a video game startup, which was developing game AI systems using machine learning. Full disclosure, I'm not a gamer. Please don't ask me questions about video games. But it was really interesting to go into a completely new sphere and look at completely new data and some new problems. So the goal, well, my role here rather, was that I was going to lead the R&D of a new tool that would automate how non-player characters make decisions in video games. So let me just explain that quickly. So AI systems in video games are kind of what's behind the AI players or the non-player characters or NPCs in the game. So amazingly, and this still stuns me to this day, even at the big video game companies, they have people who write out all the decisions that these characters can make throughout the game manually. Yeah, it's like a crazy amount of work, even for the big companies. And then that means it's almost impossible sometimes for like small indie studios who might just have a couple of employees, because as you can imagine, there's just not really enough capacity to do all that, that scripting by hand. So the problem is pretty inherent there. There weren't enough experts available to write out all this work. And even if there were, it was hugely inefficient. So at the time, we were part of an accelerator called Next AI, which is a program to help startups scale up really quickly, find technical expertise, and then often the investment necessary to have a really successful startup. So I'll take a quick moment to say, like, I highly recommend programs like this if this is something that you're into. Next AI has cohorts both in Montreal and Toronto, and it's a really, really great program. But just taking a step back from that, so I basically found myself in the situation, to my surprise, of being the only engineer on the project, in a bit over my head. But with the help of the accelerator, I soon laid out a plan to develop a reinforcement learning model. So as some of you may know, reinforcement learning is a bit of a newer branch of AI, but it was already showing a lot of promise for tasks where you needed to train some agent to do something. So it was being applied in robotics, for example, and we were starting to see some pretty robust applications in video games too. So what we did was we built a reinforcement learning model that was trained on how humans played a particular game. So we brought in a bunch of people, we had them play the game a bunch of times until they beat it, and we collected like tons and tons of rounds of gameplay. And then we kind of fed that into the algorithm so that we trained these little automated agents on all those actions. And eventually they learned how to play the game in like a human-like fashion. And once we had that data, the results could become decision trees that generated themselves. And chiefly as well here, that it wasn't just cold hard logic to like figure out what to do in the game. These decisions were reflective of how humans themselves played the game, which made gameplay a lot more realistic. So the take home here is that, obviously tools like this mean that indie game studios can compete with like the big video game developers of the world, like Blizzard and Ubisoft. And that had the potential to really change the landscape of the video game industry. So it was a very interesting thing to work on. So just taking stock of what I'd seen so far. So at this point, I'd seen data science bring game-changing insights into academic discussions. I'd seen it make companies more competitive by doing work faster. And, it potentially revolutionized what video games could look like in the future as well. So I thought at this point, if it can do all that for these industries, what can it do for geopolitics, which is, of course, my area of study. So I took some time off to develop a nice, shiny developer portfolio because my plan was to get hired as a developer in something related to geopolitics. So to do that, I was consistently using geopolitical use cases for my projects. So for example, a heat map of like where in the world the news was occurring, like things like that. But my plan didn't go quite according to plan. I realized that developer jobs, the sort of jobs I was hoping to find, didn't really exist yet. It's not really standard in the industry to hire developers to do this kind of thing yet. So I also found that people were more interested in the actual demo projects that I'd made that applied data science to geopolitics than they were in my actual like technical skills per se. So they started offering me contracts and I thought, okay, well, that's close enough to a job. So I started a company to take on those contracts where I also got into an accelerator of my own. And then there I came up with a business plan for a new AI-driven product for geopolitical risk. So at this point, I'll just take a second to explain what I mean by geopolitical risks. So these are things like protests or strikes or violent conflict, which are less related, which are kind of related to the general political landscape. So it's less so actual policies or like the inner workings of government, rather it takes a bit of a broader view. And this means watching developments in the world that might pose a risk to businesses in an area that's experiencing that risk. So for example, you could have like a non-governmental organization who might be interested in protecting their personnel on the ground from some deteriorating security situation, maybe brought on by like violent protests or something. If you're a supply chain company, you might be wanting to watch places that have house your key facilities in case they come under attack or something of that nature. And of course, the biggest one that we've seen in a really long time is, of course, Russia's recent invasion of Ukraine and all the knock-on effects of an event like that. So this meant that the problem at hand was basically that unidentified geopolitical risks cost businesses money. So when a geopolitical crisis occurs, businesses that are not prepared can lose millions of dollars every week. As you can imagine, that could mean from missing employees, scale down production, all sorts of things. So it's a very costly thing for companies to experience. And what made this worse was that traditional geopolitical risk forecasting couldn't quite keep up and definitely needed some improvement, because we've kind of witnessed the explosion of information available online, all these different sources all around the clock. But our analysis methods didn't really match that pace of growth, if you will. So most of the time when this is done, we're looking at like companies that have teams of human analysts who sit there all day and read the news in a language they understand in the time they have at work, and then they try and distill what's going on into some sort of forecast. So again, it's pretty analog, not really a data-driven strategy. And that is also something that's like increasingly less popular for their clients, because people want to know, well, what's the data behind this? Like, why did you say this? And those are becoming questions that are increasingly hard to answer. So Geopolitica is releasing a web platform called Delphi, which predicts geopolitical risks faster by using AI. So the platform leverages machine learning algorithms that are global, scalable, instant, more or less instant, certainly within the hour, which really allows kind of the processing of this information to happen on a much, much faster scale. In addition to that, it also tracks key risk trends and changes over time. As you can imagine, this is useful for businesses who have to kind of react to an ongoing situation. So we really want to be keeping track of how those events evolve and what their likely trajectory is. And then in future, we're going to go on to predict really major events and then their impact on businesses by industry. Because as you can imagine, even with a couple of examples I've thrown out, supply chain companies might be interested in different things than NGOs might be. So we're going to customize models that suit those exact needs. So let's talk about how it works. Geopolitica's algorithm is basically based on automating the best of human-driven analysis. So the data pipeline is aimed to actually mimic the work of a human analyst by identifying key features in an automated fashion to detect future patterns of behavior. So we start by bringing in data from a variety of sources. So for example, we bring in headlines and articles from global news outlets. We also look at the sentiments surrounding some of these events on social media, such as Twitter. Then I bring in proxy data, which are things like financial market trends or commodity prices that might not be directly related to geopolitics, but there are often strong correlations. And then we have access to some really great conflict databases. There's one called ICEWS, which does a very good job of collating what's going on in the world and also classifying what those events look like. So is it a major war or is it like a minor skirmish, things like that. And then we bring in sort of more macro level data as well. So macroeconomic indices, democratic health indexes, things like that, that sort of provide a really good foundational layer for our risk scores that kind of show the underlying structure in place upon which any risk might develop. So I'll note that actually for the prototype I'm going to show you today, it was built using only the data from news outlets, which we thought might not be sufficient, but actually turned out to have some pretty good results. So the next step here, regardless of whether it's the prototype or the full scale version, we do feature engineering on these sources. So that means we're extracting only the bits of information that are useful for risk forecasting. So that means pulling out useful place names, topics, or any repeating pattern really that tells a story. And then those features are fed into a time series forecasting algorithm. So I'll take a second here to say kind of like, well, why a time series forecasting algorithm? So the goal here is really to project out what's likely to happen in the next couple of weeks in a given country. So for example, there are some different approaches to this. Some have viewed it as more of a classification problem to say, okay, well, what kind of event is the most likely to happen next? Again, minor skirmish or all-out war. But I prefer to look at things a little bit more linearly, because a lot of what we're hearing from business decision makers is that they need numbers and they need timeframes. So, pardon me. So time series forecasting allows us to quantify ongoing events into a sort of volatility score. And then we can illustrate how that volatility score is likely to evolve over the next couple of weeks. And then that allows businesses to visually see basically how a risk is going to evolve going forward. So it looks a little bit like this, kind of like track the past changes. And then as we go into the future, we kind of have a bit of an estimate about how that volatility is going to evolve. So the output, as I said, highlights that trajectory. And then these forecasts become the basis for charts and other measures throughout the platform. So basically, this kind of constitutes the back-end AI engine that drives the app, Delphi. And so let's take a look at what it looks like on the other side. So what I'm about to show you is basically the prototype interface. Bear in mind that this is just powered by that news outlet data and was really just intended to illustrate what the algorithm can do. And then we're really going to polish it up in the next few months here. So yeah, here's a bit of an idea of what you see when you first log into Delphi. And I think the first thing you see is the heat map. So just taking a bit of a look on that. I built this heat map after finding out how many people were frustrated that there was no easy way to see exactly where the news was taking place at a glance. So this is a heat map that basically shows how many times a country was brought up in the news in the past 24 hours. And if I recall, I took this screenshot around February 27, I guess it says in my notes, February 27. And then that was kind of, the early days of Russia's incursion into Ukraine. So at that point too, the EU was starting to respond with sanctions, and you can see that by the darker colors there on the map. So this currently updates every hour and takes into account all events from the past 24 hours, but work is already underway to make this a real-time data pipeline that will update instantaneously. Okay, and this is one of my favorite parts. So this is the latest algorithm results that produce that volatility score. As you can see, this one was done on February 18th, or the Friday before Russia invaded Ukraine. So I was pretty excited to see a volatility score of 90% come out for Russia, as that's correlated strongly with the threat of invasion. And I actually had to engineer a higher threat ceiling to accommodate all the activities surrounding Russia. So it was a really interesting development case. But from there, we also see, high scores for Ukraine for obvious reasons, but also we see countries such as Mali. And at this point in time, that was reflecting that there was a recent coup and French troops were withdrawing from the country, which had sparked some geopolitical risks. So we'll take a little look at that a bit later on, so I can show you some more information. And then, but yeah, so you kind of get the idea. I was also quite interested in Germany's score here because within the 2-week timeframe after this algorithm result came out, Germany did actually increase their defense budget to align with NATO standards. So that was kind of a bit of a surprising development in Germany, which is usually tends to fly pretty under the radar. So bear in mind, these were preliminary scores coming from a limited amount of data. So we're really excited to keep developing these in the next phase. So elsewhere on the app, from there, you'll see that there's a news feed bringing up all those stories in chronological order. Our data pipeline only counts news if it talks about a country, a region, or a politician. And despite only having a few global news sources in the prototype, this has ended up being more than adequate coverage for the algorithm. So you'll see some of those features I was talking about illustrated here. We have the countries, we have the news source, and a collection of topics being extracted from the text. I wasn't super thrilled with this version of the topics, so they're being upgraded at the moment, but they've already proven useful in anchoring news that kind of straddles multiple countries or regions. So for example, a topic that I've been looking at over the last couple of weeks has been just NATO and all of the countries involved in NATO and that ongoing discussion. So these effectively form the building blocks of the application, and I think we'll see some more of them right now. Okay. So here's that country level page, and I decided to focus on Mali to kind of take a deeper dive into what was meant by being a country to watch. So first, you can see that there's a small paragraph of analysis. This was written by a human analyst and is intended to summarize the rest of the information you see on the page. And this was added because market research indicated that clients weren't ready for 100% automated analysis yet, and I think it also just serves as a nice starting point as well. So from there, you can see the 14-day volatility outlook. So this is a snapshot from the end of February when that French withdrawal was occurring. So you can see that it really wasn't predicted to be a high ongoing risk, as you can see from the light blue continuation of the graph. So this indicated at a glance that this particular risk was predicted to be a spike in volatility that would ultimately settle to a moderate but ultimately stable risk level going forward. And that would contrast with something like the ongoing crisis in Ukraine, which is projected to be a much higher risk for a much longer and sustained amount of time. And then finally, we have our Mali-specific news feed now off to the left. And that also updates once every hour, and we'll soon move to real time as well. Elsewhere on the page, you can see a Mali-specific news feed continue, and then a couple of other modules. These are somewhat still in development, but you can see one kind of visually summarizes Mali's coverage in the news over a 3-month period. So that allows us to take a step back from that 2-week forecast. And then it also includes a country profile with some useful information. For example, I didn't know Mali's population was that large before I did this, so that's good to know. And the bordering countries are being included in service of a future feature that will focus on the proximity of risks in neighboring countries. So that's your kind of snapshot of Delphi and how the product is coming together. So where do we go from here? So look, in not to be blunt or anything, but I kind of just hacked my way here. So we're getting out of the hacking stage soon and really starting to scale up. So that's going to start with a huge data exploration period over the summer with the help of some interns. So that is going to greatly expand the data being ingested. It's also going to focus more on detecting those trends that I was talking about. We're also going to be developing new measures that are more useful to businesses that illustrate changes in an ongoing geopolitical situation. And then we're taking that to Collision Conference in Toronto. So that's North America's largest tech conference, and Geopolitica was selected as a featured startup exhibitor. So if anyone's at Collision this year, look me up. I'd love to say hi, because I'll be in the area. And then from there, we're getting the capital ready right now to massively expand the development team and then do a really intensive R&D cycle sometime around the fall. And that is basically going to pave the way from like prototype to a fully commercial application. And I'll also mention at this stage that this will be leveraging some R&D programs from the Canadian government and the Quebec government, which will significantly subsidize the cost of the project. So if anyone has ambitions in this sphere, I just wanted to mention that there are some really great programs and methods of support to get these things off the ground. And it's a really great time to be involved. So after that, an intense testing stage will kick off, consisting of 2 rounds of user testing with applicable industry sectors. And then that means that just ahead of 2024, we should be able to launch a fully commercial product to the immediate market and hopefully watch it grow from there. So thank you very much. I appreciate you taking the time to listen to me, and I'm looking forward to answering your questions.
Thanks, Britt. That was absolutely amazing. I feel as though you've built Bloomberg for geopolitics. I don't know. In my past life, you'd just be on Bloomberg all the time. You'd have events come in and then you trade on them, right? And I feel as though that's kind of what you've built. It's amazing. Our traditional first question is, what are some books that you recommend? But I might just usurp that one by saying, can I have a job? So 2 traditional ones. And then if folks have other questions, please raise your hand and then I'll call on you. So job.
Oh, right. Oh, can you have a job? So right now we've kind of got like a moving landscape, as you can imagine, with a startup. So but we will be hiring a bunch of specialists towards the fall. And I will also say that we're also looking at ways to kind of amass some volunteer involvement as well. We do tend to get like a pretty good amount of interest in this sort of project, and I would like to leverage that interest if at all possible. So basically watch this space. There might be a way to get involved. I was also preempting the book question just a little bit. So I grabbed some off my shelf. So I do have like a couple of kind of technical books and then non-technical ones. As I mentioned, I'm mainly self-taught, so I really appreciate books that act as kind of like a reference point. So I have this one, Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow by Aurélien Géron, very French-looking name. And this was a really good one for me because it comes with like checklists and like best practices built in that you can kind of follow along with as you're doing your own machine learning model. So I felt that was, like a really great way to bake in those best practices, even when I didn't have a lot of supervision, as it were. And then I have another really interesting one for anyone who's interested in data engineering. You can see I use it a lot with my Post-it notes. This is Designing Data-Intensive Applications by Martin Kleppmann. And this one's also been a really great reference, lots of good stuff. And I also learned tons about like how computers actually work, you know, closer to the metal, as it were, which will really help my kind of fundamental understanding of computer science. Another one, this is obvious for anyone in the startup space, the Lean Startup, Eric Ries. It's kind of the startup Bible at this point. You don't have to agree with it, but it will explain a lot of what's going on. So that's a good one to read. And then kind of outside of any specific niche, I also have The Black Swan by Nicholas Taleb. I think it's subtitled, The Impact of the Highly Improbable. So you can see how that would be interesting. And I really appreciate that he takes both a philosophical but also statistical approach to things. And it also has like the best bibliography ever. It's like jam-packed with like all this crazy stuff. So even if you don't read the book, look at its bibliography because it's pretty crazy. And so those would be my book recommendations.
Perfect. Thank you very much. So I'll stop recording.